Okay, what is going on? It's Coding with Shaf, and today I am going to do a LeetCode medium problem called max twin sum of a linked list. It's February 25th, 2022, and it looks like Russia has invaded Ukraine, and the world is going to shit. And the only thing we can do now, right now, is do some coding to get our mind off of this whole mess. Anyway. Yeah, so this is a linked list problem. It's medium. I'm right away. I'm looking at it, and I mean, there's like a super easy way to solve that. It probably defeats the purpose of this problem, but I'm gonna do that anyway because I'm gonna see if it works or not. The problem is called in a link. The problem description is it has also 341 people who like it. So, and I know in an interview you're supposed to give a optimal problem, optimal solution. So the solution that I'm uh, going to put here, I'm pretty sure is not the most optimal. These linked list problems are tricky and involve manipulation of the pointers in a linked list and whatnot, and I just want to solve this real quick so I can just see if it works, and I'm pretty sure it does. But the description is in a linked list of size n, where n is even, the ith node in x0 of the linked list is known as the twin of the n minus 1 minus ith node. If 0 is less than or equal to I is less than or equal to n over 2 minus 1. For example, if n is 4, then the node 0 is the twin of the node 3, the node 1 is the twin of the node 2. These are the only nodes with twins for n equals 4. The twin sum is defined as the sum of the node and its twin. Given the head of the linked list with an even length, return the maximum twin sum of the linked list. So basically what this is saying is that we have this linked list and we want to have two pointers iterating inward, right, towards the center. So the twin sums are going to be 5 plus 1 and 4 plus 2, and we find what the maximum of those are. In this case, both are 6, so the max is 6. In this case, 4 plus 3 and 2 plus 2, the max is, that's 4 and 7, so the max is 7. And in this case, there's just one twin, and so the sum is 100,001, and the max is 100,001. Okay, so basically, fairly straightforward description of what's required, and I'm gonna take the easy way out and solve this in the easiest way possible. But you can solve. I'm pretty sure you can solve this in a more complex way by maintaining two linked list pointers and then unhooking the pointers and going backwards or recursing through the linked list and then adding the value to each of the nodes as you go through the linked list. Maybe I'll do that in a subsequent video, but for now I'm just going to try to get something out there. So the first thing I'm going to do is create an array list integer of nodes equals new array list. Okay, and the reason I'm doing this is because you probably guessed it, I'm going to store the linked list nodes values within this integer array. Okay, the whole point is that I want to make it easy to access elements of this linked list, right? So sometimes the most straightforward way to do that is at the expense of some extra space is to create another array that has the values. And this doesn't always work, right? But this is something, sometimes it does. Like in this case, I believe it will. So basically what I'm going to do, I'm going to add the nodes values to the linked list by iterating through the linked list with a simple one pointer solution, pointer.next. Okay, so that should give me all the values of the nodes in the linked list because I'm going to go until there's no more nodes within the list. So pointer, 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 and null. And then the rest of that is a matter of iterating to the middle of this array list. Remember, it's always even, so the middle is pretty determinate. Divided by 2, right? So that's the middle, I plus plus. And so remember, we have a value for the twin sum is 0. So twin sum twin sum equals max twin sum, right? So I'm getting the max of any twin sum detected already. Get the ith node plus nodes dot get nodes dot size minus I minus 1. Okay, so basically what's happening here is this is the twin sum, nodes that get I, we're getting the ith value, so this is the ith value, 0 in this case, and the nodes that dot size minus I minus 1 would be, nodes dot size minus I would be 4, and then remember minus 1 because we have to we can't start at the length of the list if we're iterating backwards. We have to start 1 minus the length. Okay, so let's see if this works. We're missing, we need to return the twin sum. Turn twin sum. Okay, that should work, and then I believe running it, yes, so it wasn't terribly fast or terribly space efficient. In fact, it was pretty space inefficient, but like I said, I believe a faster way to do this would be maybe recursion or something like that. For now, I'm just happy getting this done. Okay, if you like this video, like, subscribe, comment below, and don't forget to follow me and hit the bell icon and all that good stuff. I will see you around in the next video. Bye-bye.